Fill in the following chart. The first column is already done for us. Before filling in columns B, C, and D, let's make sure that we understand column A. We're given the initial value is 50 and the doubling time is 30 days. So if we create a table of values, for the initial value of 50 we can enter a t value of 0 and an output of 50. The initial value is 50. The doubling time is 30 days. So that means that when t is 30, the output of the function will be 100, and that can be found by taking 50 and multiplying by 2. After another 30 days goes by, on day 60, the population will be 50 times 2 times 2, or 50 times 2 squared. After 30 more days, on day 90, the value of the function will be 50 times 2 cubed. Notice that each of the outputs has the same form. It has a constant times a power of 2. 50 times 2 cubed, 50 times 2 squared. This one we could write as 50 times 2 to the first. And the first one, we could even write that one as 50 times 2 to the 0. So when we write a formula for the function, we'll write f of t is equal to the initial value of 50 multiplied by 2 raised to some exponent. Now it's tempting to put the exponent as t, but notice that t and the exponent are different. 90 and 3 are not the same. 60 and 2 are not the same. In order to get the exponent from t, we need to divide by the doubling time, which in this case is 30. 90 divided by 30 is 3. 60 divided by 30 is 2. 30 divided by 30 is 1, and so on. So we need to raise 2 to the t divided by the doubling time, which in this case is 30. In general, our formula will have the form f of t is equal to c times 2 to the t divided by d, where c is equal to the initial value and d is the doubling time. What is the growth factor per unit of time? Well, what we've seen is that the growth factor is 2 if we... So now that we have our exponential function, what is the growth factor per unit of time? Well, what we need to ask ourselves is, what do we multiply by as the t value goes up, not by 30, but as the t value goes up by 1. So let's make a table of values to explore. And once again, we start off with t is equal to 0. The initial value of the function is 50. But this time, instead of increasing t by 30, we increase t by 1. As we increase t by 1, we can substitute the values of t into the formula to determine the corresponding output. So when we substitute 1 for t, we get 50 multiplied by 2 to the 1 divided by 30. Notice that 50 has been multiplied by 2 to the 1 over 30. So 2 to the 1 over 30 is the growth factor per unit of time. So that's where the 2 to the 1 over 30 comes from. In order to get the 1.0234, we just evaluate 2 to the 1 over 30 on our calculator. 2 raised to the, in parentheses, 1 divided by 30 gives us 1.0234 rounded to 4 decimal places. If we were to substitute in 2, then we would have 50 times 2 to the 2 over 30. And notice that that's exactly what we would get if we multiplied the previous result by 2 to the 1 over 30. And similarly, if we substitute in 3, we would get 50 times 2 to the 3 over 30. And that's just what we would get if we took the previous result and multiplied by 2 to the 1 over 30. So 2 to the 1 over 30 is the growth factor per unit of time. What is the growth rate per unit of time? Well, in order to answer that question, we'll convert the growth factor to a percentage and compare that with 100%. Because if something doesn't grow or it doesn't decay, then it remains at 100% of its original amount. So we want to compare the growth factor with 100%. So we write 1.0234 as a percentage. That's 102.34%. And we notice that that is bigger than 100%. So that corresponds with growth. So we'll take away 100% to determine the growth rate per day. 102.34% minus 100% is equal to 2.34%. And notice that that corresponds with our growth rate per unit of time. All right, let's go ahead and try to complete columns B, C, and D. For part B, the initial value is 1,000, the doubling time is 7. So we'll use our function formula from below, and we'll substitute 1,000 for C and 7 for D. So that gives us f of t is equal to 1,000 multiplied by 2 raised to the t divided by 7. In order to determine the growth factor per unit of time, we just need to evaluate 2 and then substitute 1 for t, so we get 2 to the 1 over 7. When we evaluate that on our calculator, we get 2 raised to the 1 over 7 is approximately equal to 1.1041. To get our growth rate per unit of time, we convert that to a percentage. That's 110.41%. So that indicates that our growth rate per unit of time is 10.41%. And I should be indicating the per unit of time. In this case, our time is years. So we have 1.1041 per year and 10.41% per year. For part C, our initial value is 4, our doubling time is 25 minutes, so our function will be f of t is equal to our initial value of 4 multiplied by 2 to the t divided by the doubling time of 25 minutes. To get the growth factor per unit of time, we evaluate 2 to the 1 divided by 25. That's approximately 1.0281. And this is per minute. To figure out the growth rate per unit of time, we convert the growth factor to a percentage. That's 102.81%, which is 2.81% more than 100%. So the growth rate per unit of time is 2.81% per minute. Okay, finally, in part D, we're given that the initial value is 5,000 and the doubling time is 18 months. So the function is f of t is equal to 5,000 multiplied by 2 to the t divided by 18. To figure out the growth factor per unit of time, we evaluate 2 to the 1 over 18. That's approximately 1.0393, and that will be per month. And finally, to calculate the growth rate per unit of time, We convert the growth factor to a percentage. That's 103.93%, which is 3.93% more than 100%. So our growth rate per unit of time is 3.93% per month.